Hi all. For the last section for chapter 14, we're going to talk about areas, volumes, and similarity. Areas, especially surface area and volume, is influenced by scale factors in a different way that you might predict. So let's take a look at a couple of examples and see if we can determine this relationship. So here I have a diagram of a rectangular prism, and in the table up here I have the measurements of the length, width, and height, and they are corresponding to the length, width, and height of the box on the diagram. Also, in order to calculate surface area, I have the net of this prism with the length, width, and height of the box on the net. So, I also have calculated the surface area of the original box and the volume of the original box here on the table. Now, what we want to find out is what is the impact if we create a similar figure using different scale factors. And in this case, our scale factors are 2, 3, 5, and then we want to see if we can figure out an overall relationship between surface area and volume of similar boxes or similar figures. So let's get started on that. And let's start with a scale factor of 2. So for a scale factor of 2, we're multiplying the length, the width, and the height by 2. So our length instead of 5 would be 10, width would be 6, and height would be 8. And we can change that on our figure down here. 10, 6, and 8. And now you might predict that because our scale factor is 2, our surface area is going to be multiplied by 2. That might be a good prediction. However, it would be incorrect. Similarly, with volume, you might predict that we're just going to multiply the volume by the scale factor of 2. That is not how it works. And let's see what actually does happen. So here, let's look at surface area first. So for surface area, we have 2 times 10 times 6 plus 2 times 10 times 8 plus 2 times 8 times 6. And so 2 times 10 times 6, 10 times 6 is 60. 2 times that is 120. 10 times 8 is 80. 2 times that is 160. 6 times 8 is 48. Times 2, if you need your calculator, it is 96. So 96 plus 160 plus 120 gives us a total of 376. 376 square centimeters. Now you can see that that's a lot more than just 2 times. So if we did 94 times 2, we would predict that we would get 188. Instead, we get 376. That's a lot more. Let's figure out what that difference is. So let's take 376 and divide it by 94. 376 divided by 94, and we get a scale factor of 4. Oh my. So instead of 2 times, we're actually multiplying it 4 times. Interesting. All right, let's check out the volume, the difference in volume. So here again, our length is 10, our width is 6, and our height is 8. So 10 times 6 times 8. 6 times 8 is 48. Times 10 gives us a total volume of 480. So 480 centimeters cubed. Again, a big difference. If we did 60 times our scale factor of 2, we would expect to get 120, but instead we're getting 480. So let's see what that difference is. So 480 divided by 60. 480 divided by 60 gives us a scale factor of 8. Wow. So instead of a scale factor of 2, for surface area we have 4, and for volume we have 8. So let's see if we can do one more and see if we can figure out a pattern. So let me erase all of this on the bottom here. And this time we will do 3 times. So we're doing a scale factor of 3. So instead of 5 for the length, we have 15. 3 for the width, we have 9. 4 for the height, we have 12. So let's change our numbers. Here we have 15, here we have 12, and here we have 9. So to find our surface area, if you remember, we're going to do 9 times 15 times 2 plus 2 times 15 times 12 plus 2 times 9 times 12. So 9 times 15, don't be afraid to get out your handy dandy calculator, times 2, 270 plus 15 times 12 times 2, 360 plus 9 times 12 times 2, 216. So 216 plus 360 plus 270 gives us 846. Don't be afraid to pause the video at any time and try this on your own and check my work. Don't just trust me, believe me. All right, and then for our volume, we have 15, 9, and 12. So 15 times 12 times 9. 15 times 12 times 9 is 1620. So 1620 centimeters cubed for our new volume. All right. So again, we have a lot more than just 3 times 94, right? So let's see what our ratio is here for 846 divided by 94. 846 divided by 94 gives us a ratio of 9. So instead of 3 times, we're doing 9 times. Let's check the volume. 1620 divided by 60. Interesting. So, do we see a relationship? And if you know your squares and your cubes, you may see the relationship. So over here, instead of k times, we want to do k times the length, the width, and the height. But for surface area, instead of k times, we're doing k squared. Notice that 4 is equal to 2 squared. So whatever our scale factor is, we're doing that squared times our surface area will give us our new surface area for our similar box. For volume, instead of multiplying times our scale factor, we're going to multiply times our scale factor cubed. So notice here, 8 is 2 cubed. 2 times 2 times 2 is 8. So we're cubing our scale factor. And that's true for 3 times. 3 times 9. I'm sorry. For our scale factor of 3, 9 is 3 squared. And 27 is 3 cubed. A good way to remember this is remember here we're using square units for our surface area. So we want to square our scale factor when we're doing similar figures. For volume, we're using cubic units. So we want to cube our scale factor to find the volume of a similar figure.